Well, it's nice to be here again, but wait a minute. Lights. Who put off the lights? Maybe a fuse blew. Oh, there it is. Fine. No, fuse blowing. Ever happened to you? End up in the dark? Well, this can be a very annoying situation, and it can also be a serious situation. We want to explain to you what actually happens when fuse blows. Want to come into my kitchen? Right here. Doesn't look like much of a kitchen, but it's a special kitchen. Oh, this isn't the broom closet. This happens to be a wall that opens. And I'm going to open it and, well, maybe I won't show you what's doing back there. Did I? All right, well, let's take a peek. Nope, no mops, no ironing board, just a wire. Now, this happens to be a part of the wall that opens purposely to let you see one wire of the circuit. Now, I'm going to put on my overhead light in my kitchen, and we see that we're all set to go to work. I don't have enough light, really, so I'm going to plug in another light. Here, a little lamp, plug it in, and give us a little extra light. There's my lamp. Okay? Now, since we're in the kitchen, we should have a few other appliances hooked up, and let's all get all these hooked up so that we can use them. But unfortunately, I really don't have very many plugs, but I've added an extension cord right here to my kitchen wall socket. Maybe you have the same thing at home, and I'm going to plug in the refrigerator. Here we have the refrigerator and the lamp. Now let's watch a little TV set with a nice long extension cord while the food is cooking. Let's see if I can squeeze in the TV set. And also, I'm going to cook the meal, so I'm going to plug in the broiler. Everything on the one line. Here we go, plug in the broiler. Now the food is broiling, the light is on, the refrigerator is working, and I'm watching television. Now everything is fine, except we have to be very careful because look at the wire in the wall. Now a lot of electricity is forcing its way through that wire. And if we're not careful, this is the situation that can result. Fire. Fire within the wall. Now, why do we have this situation? Well, electricity itself may be compared to water. And we could practically say the electric wire is like a pipe. A pipe that will allow water to go through it is a water pipe. But a pipe that conducts electricity might be considered a wire. Now, if we force too much electricity through, or excuse me, too much water through our pipe, pipe might burst. Now, the same thing happens with electricity. If we force too much electricity along the wire, or allow too much to go along that wire, then the wire will heat up. Now, here's a demonstration that I've made, and you can make one just like it to show this principle. We have here our regular circuit. Wire coming from a battery, right here from the dry cell, through a bulb, back to our dry cell, and the light works. I've added two extra little things here. They're called alligator clips. These little alligator clips, you may find them right in your classroom. Most classrooms have them. These alligator clips are holding another piece of wire. Now, for this type wire, the piece of wire that I have here, I have used iron wire or iron picture wire. Here's a piece of it. Let me see if you may have it right in back of the pictures at home. It's a type of wire that's stranded. There's a lot of pieces all wrapped together. Now, I've taken a piece of this iron wire, and with a pair of pliers, I've drawn out one little section. Let's see if I can pull out one piece. There it comes, see? Pulled one piece of iron wire right out of the whole unit. Now, this iron wire I have placed across my alligator clips. Now, to point up or make it a little easier to see what I'm going to do, I'm going to take some absorbent cotton, just a little piece of it, and wrap my iron wire with the absorbent cotton. Now, we're going to make believe that this is the wire that's in the wall. Now, we have put in too many appliances, and we saw what happened to the wire in the wall. What would happen if we allowed this wire and this wire to touch? we would allow a lot of electricity to go through as fast as it possibly could, or as much as possibly can go through. Now we'll see if our wires will handle this much electricity. I'm going to pinch these two wires together. Notice the bulb has gone out. My iron wire has heated, and this would result in fire. Now here we have produced what we consider a short circuit. A short circuit, allowing the wires to touch so that too great a quantity of electricity will try to rush through these wires, and the wires overheat. Now these short circuits may occur in your house by something like this. Does this look like your broiler cord or your mother's ironing cord possibly? If it does, time for a change. Or even your own lamp cord at home may have gotten pinched by the door, or the chair may have been pushed against it too hard. You may have this kind of situation in your wiring at home. Now just putting tape around this wire won't do any good at all. In fact, most likely it'll be even worse, because this wire would be pushed against the other wire, and we would have a short circuit. Now, the cause, improper wiring. The result, short circuit and heat. Now how can we protect this? One of the ways we protect it, and here's where my alligator clips are going to come in handy. I'm going to squeeze them and allow this wire to be released. Okay? One of the ways we can prevent this type of fire is to put a piece of wire in here, which is very thin. It's wire called fuse wire. I have some on a coil here. Take off a little piece of it. Now this is called fuse wire. And this fuse wire is the regular fuse wire on the science list. When we put under this side of the alligator clip and under this side. Now, get my alligators to hold nice and tight. Just clip off the extra. See if we have electricity going through. Yes, we do. Now, let's see what happens to our fuse wire when we get a short circuit. Now, push these together. We have a short circuit. The fuse has melted. That piece of fuse wire melted off completely. No fire, but an immediate melting. Now, this idea of fusing is used within your own house. In fact, if I go back to my kitchen and shut off all my appliances, I'm going to put in a fuse right in my fuse box on the wall. That's something we didn't use before. We didn't use a fuse box. Now, this fuse will be just like my fuse wire that we saw on our own demonstration. Now, let's watch the fuse. There's a little piece of fuse wire right in it. I'm going to turn on my appliances. Now, you just watch what happens to my fuse wire when I turn on the appliances. We all set? Here we go. Turn it on. There's the fuse. See that? That fuse wire has actually melted. You saw a little flash in there. A small fire took place, but it took place within the body of the fuse, so that there were no fires in the wall. The fuse itself stopped the electricity from flowing. The reason for that is that a fuse is a bridge of metal which allows the electricity to flow. Now, in the circuit, the electricity would flow into the top of the fuse, through the fuse, and out the side. You notice how nice and thin it is here? Now, this small, thin section is a section which melts. Being thin, it heats up and melts faster than the wires in your wall. Now, that's a screw-type fuse, and this is the fuse that you are very familiar with. In fact, here's one right here that might be just like the one you have at home. Standard screw and fuse. And let's look in the back, see if we can see that little bridge of metal. There it is. Little bridge of metal located right in the back of the fuse. Now, some fuses are circular fuses, or plug fuses like this. Here's another type of plug fuse called a fuse stack. Some of the newer homes have these. But you may also have a fuse that looks like this. There's a cartridge fuse. Within the cartridge fuse, we would find that there is the same type bridge of metal. Now, this is a bigger fuse for industrial purposes, and we allow more electricity to flow through this fuse. Now, we have all kinds of fuses. We even have cartridge fuses that look like this one here. Look at this. Here's a fuse. And looking at the bridge of the metal, instead of having a little notch in the center, they've actually hollowed out the center of the fuse wire. So a fuse like this might fuse a whole apartment house to make sure the whole apartment house doesn't draw too much electricity. Now, these are fuses. The fuses themselves depend upon a small bridge of metal which allows electricity to flow. Now, how is this bridge of metal put in the circuit? The bridge of metal itself is put into a circuit very similar to the way we show on our chart. We allow the electricity to flow in the circuit from our battery through the bridge of metal, through the fuse, and we'll say right here, through our light, back to the battery. This fuse, if it blows or breaks, will not permit the electricity to flow in a circuit. Now, you can make your own little fuse demonstration unit by using some of the things that we've learned about already. Now, the first thing I've used here is our battery holder. Now, your class may have regular battery holders, or you can use dry cells. In this case, I use a little battery holder that we made with the rubber band and the screw eyes. Now, here we have the wire going from the battery through a fuse holder to a bulb, back to the battery. Why doesn't it work? That's a good question. Let's tighten the fuse and find out. There. The fuse was loose, the bulb was off. Loosen it, bulb off. Tighten it, bulb on. Now, here we have a fuse in our own circuit. If, for any reason, this circuit would draw way too much electricity, then technically this fuse should blow. It would be kind of hard to blow this size fuse just using a battery, because this fuse will allow more electricity to pass through it than the battery supplies. But this shows how fusing works in a circuit. Now, when fuses blow, when they blow, that little cartridge or a little strip of foil or metal burns out. If our fuse blows because of overloading, too many appliances, too many things drawing electricity at once, that strip of metal heats up slowly and just melts. If we should have a short circuit, then pow, the whole fuse just blows at once. It burns up real fast. And we can tell the condition that caused the fuse to blow by looking at the back of the fuse. If we just look at the little window in the back of the fuse, we might see something like this. A good fuse would show us a strip of metal which is quite solid. No breaks at all within the strip of metal. A bad fuse, which has been overloaded, would just be a small, thin break right here. See, it heated up and it melted, and the piece just melted right out. A short-circuited fuse, well, that's a fuse in which too much electricity passed through at one time quickly. Now, this short-circuited fuse shows a burnt condition. The whole back is burned, the fuse has melted very quickly, and, of course, the current has stopped flowing. Now, this is a short-circuited fuse, an overloaded fuse, and, of course, a good fuse. Now, we've talked about fuses, and we've seen what's in them, and last week, we even did some work with our model house. Let's take a trip to our model house. We had installed a light in a circuit in our model house, and I asked you, how might we turn the light off and on? Well, most of you figured that out pretty well. You said, let's add a switch. And when we add the switch, let's see, there we are. Light goes on, light goes off. We've added a switch. But I've added something else to my circuit. I've added a safety factor. And that safety factor is the, that's right, the fuse. And you can add a fuse right to your model house, too. I have placed in my model house a small piece of fuse wire. held it in with thumbtacks, so that if for any reason too much electricity should be drawn through this circuit, the fuse would melt and the bulb would shut off. Tracing our path of electricity, we see electricity flowing from the battery, or dry cell, through the fuse, through the switch, through the bulb, back to our source of electricity, the dry cell. Now this model house, put the light off, is fused. Your houses are fused too. But let me give you a word of caution. Changing a fuse is not the job for you in 6th grade. This is a job strictly for an adult. This is not your province. Just fuse blows, let an adult know, they will take care of it. You are not to take care of it yourself. Don't forget that. That's a safety factor. Now, what are some of the other things that we try to get across besides safety factors? Well, our review shows us that a fuse is a bridge of special metal in an electric circuit which melts when more than a certain amount of electricity passes through it. A fuse is a bridge of special metal in an electric circuit which melts when more than a certain amount of electricity passes through it. Also, fuses break the circuit. They actually disconnect the electricity. Fuses break the circuit when the wires are in danger of becoming overheated. So if the wires are in danger of becoming overheated, then the fuse, the safety device, breaks the circuit. Now, we know about fuses, and we know why they're used and how they're used. Now, let's say we make our own fuse devices in class. I'm going to give you a little work to do. I want you to try to figure out, with teacher possibly, how, by using a switch, some wire, a bulb and socket, and a dry cell, we can make a fuse tester. That's what I said, a fuse tester, using a switch, coil of wire, bulb and socket, and dry cell. I want you to see if you can figure out how to make your own fuse tester. Now, next time we're together, we're going to continue with our study of electricity, and we're going to discuss things that use electricity to produce heat and light. Should be interesting. I hope so. Bye now.